This time on the laboratory, we're going to be working on a Department 56 piece from the original Snow Village, the Haunted Funhouse, which I've never seen in person, so this is a first for me. It has the issue of this isn't spinning anymore. Now, it's a lid house, but it has a little jumper to plug into the stuff inside. I was going to plug it in and make it work, but when I looked in through the bottom hole in here, I can see there's a broken wire, which is dangling in there. So, that might be the whole issue. Might. So we're going to open it up. Now, it has been taped back together, probably because the glue is rotted. We also have some screws, which probably hold this mechanism in place. So, let's open it up before I test it. So one, I can make sure that wire isn't touching anything important, because I don't need that wire arcing if it has a lot of power going through it. And two, the piece that plugs in right here fell inside and I can't reach it. No matter how I jiggle the house, I can't get it to pop back out. So yeah, that kind of inhibits the ability to work on it. So one nice thing about Department 56 is they tell you the name of their pieces on the bottom of the piece, because I don't have a very good memory. So I'll pull a piece out and have to look at the box, especially with Limax, to figure out what it's called. So here we go. Okay, broken wire. And then we have a set of wires right here. Oh, the motor's not even hooked up. I wonder if the motor's bad. So this is a big old synchronous motor. You've probably seen my most recent video about it. So we have a wire here, which goes to something, I would assume. Now we have a synchronous motor that's not hooked up. I need to see what power the synchronous motor is. And this wire here, they probably went together. So these are all in a bundle. Oh, we got another wire here. It's white. So LED over here is hooked up. LED over here is hooked up. LED over here is this broken wire. The LED in here is this broken wire. This, I have no clue because it comes off the circuit board. So, this one's a little bit of a puzzle. Let's see if we can figure it out. So, the main issue was, and here's the other end, it got caught under the barrel, which is why I couldn't fish it out. Now this is wired directly, and then here's your transformer that steps it down. But I need to check this motor, because this motor can be any voltage, and it might even be a 120 volt motor. So there's a ring around the little devil kid right here, and the screws to hold that ring on are on the bottom. That's 2 of the 4 screws. The other 2 screws are what holds the motor bracket in place. There we go. Oh yeah, I forgot. I started using foam now for these porcelain and stuff. We'll do that. 120 volt AC motor, 6 RPM, 3.7 watts. So this is a full power motor. So instead of probably putting it back in these wire nuts, I can just plug it into a power supply directly and find out what's wrong. Now, this motor, if it is bad, You can still buy the 120 volts. The RPM may be hard to find. Sometimes they're like 4 to 6 or 6 to 8. This says it's a solid 6. And it is a CCW, which is counterclockwise rotation. So, but the next issue is going to be where all these little lights go. So, I'm going to go ahead and plug this in now that I have it out. And we're going to see exactly which lights aren't working. Well, that light works perfectly. This one right here. I'm going to unscrew it so it doesn't blind me. And I might have to kill some of these lights because they're overpowering the house. One light. And yeah, I'll just turn them all off so I can see which ones are working. There we go. So the eyes are working. There you go, all three. His eyes are working. We got the glow on the moon. But this light down here isn't working. And there's a wire that goes in here, which I can't see where it goes. I have to turn the house onto its face. Isn't on. And then everything else appears to be fine. So the two LEDs that are broke, the wires, they're all here in the bottom section. And I'm wondering if when the bottom fell out and it was taped back in, if the wires got pulled and they broke. So I need to check the power output of the LEDs. Red LEDs run at the lowest power, green LEDs a little bit higher, orange LEDs a little bit higher. So if this was supposed to be soldered to the circuit board, then I want to make sure that I don't hook a 2 volt LED to a 3 volt power because it'll burn out. Also, if you have this house and you're working on it, this one is not as safe. Let's rephrase. Let me try and phrase it good. There's 120 volts sitting right here. And it's not over there at the wall like on the Lemax where it has the power supply on the head. This is your power supply. This guy right there. Turn the light. Makes it easier to see. That. So, on a Lemax, so you can compare, let's unplug it. Here's your Lemax head. So, the Lemax. This transformer is inside here. So the output is low voltage. It's safer. This one, the low voltage is coming out of those two blue wires right there. The red wires, 120 volts. The casing is not wrapped. It's got they're lacquered wires. But if you scratch those, there's live power there. So if you're working on a house like this where the reduction of power is inside, be careful. Because now that I've unscrewed my idiot light to tell me I do have power, I can forget. So can you, as an example, and you can zap yourself. You don't want to do that. So in this house, very important, this house and other houses that the Department 56 makes that has this jumper wire, it's full power. So you got to be safe. We don't want you don't want to get the tinglies. So you can leave this screwed in so you know that you got power on. But when I'm working here, this is a blinding light to me. So that's why I did that. And if I turn the clicker that's on the cord, the on-off switch, it kills power to everything. So I can't check the LEDs because I'm not getting the low voltage. But what you see here is basically what's inside here. So for those who aren't electrically inclined, as an example. So you have 120 volts that are just wire nutted there, go into here. These coils, step it down to 12 volts. Most likely it's still AC. And then on this board, there's probably a rectifier that makes it DC. It doesn't matter. The LEDs will come on in AC. They just flicker. You probably won't even notice it because they have a chip that makes them turn on and off, except for the light here. So, but So I'm going to go ahead and turn on the lights, and I'm going to get my Variac out so we can test this to see if it actually turns. And most likely isn't unhooked because it doesn't turn. It's probably a bad motor. And then I'll have to order one of those because I do not have any 120s on hand. I have 6 through 24 volts AC and then a 240 volts AC. I do not have any 120s on hand. They're not common. I've only worked on one ever, and I ordered a part for it and just replaced the motor. This would be number 2. The first one was a generic Mr. Christmas. It looked like a Mr. Christmas, but it was just a generic knockoff. So I'm going to go ahead and pause the video, move all this a little bit out of the way, and then check to see if that's any good. And then I'll undo the circuit board, which is just glued down, and find out where these wires are supposed to go and check what color these lights are. I'm assuming these 3 eyeballs right in, or excuse me, yeah, 3, 1, 2, 3, are probably like this: red and green and yellow. So we got 3 colors there. Actually, the bottom ones are red too. This one's got 4. But I don't want to send the power for the yellow to the red because it's too much power. It's a higher voltage. So anyhow, very easy to take apart, as you saw. If yours isn't glued on still, just take the bottom out or break the glue off carefully, heat it up if necessary. Pull the base out, be careful. These are very, very small wires. They're like 28, 30 gauge. And if you have it plugged in, try not to mess around in the high power section. You don't want to, one, blow the transformer or electrocute yourself. So I will be back in just a few moments once I get the lights back on and unplug it and make it safe and move it out of my way so I can check this motor. Alright, I got the house out of the way and hooked this up to a jumper cord I have. That. I'm going to say it's a bad motor. I can hear it. It sounds horrible. And I did an ohm check. You can actually, if you don't have a machine, you can use a power strip. Still don't recommend it. And plug this into the power strip and then click the on off. So if it is shorted, it trips the power strip. But the motor has 1.83 kilo ohms or 1,000 ohms across the windings. That's way too high. The ohm should be like 10 or 4, like no joke, not 1.8. So I'm going to say it's a bad motor, but I'm still going to plug it in for science and test it. So first thing I do is my machine's set for right around 9 volts from the last project I was working on. So set for AC, 9 volts. So when the lightning bolt comes on, or the lightning bolt, let you know that you're now in dangerous territory. It's enough power to kill you. So this motor is 120 rated, so we'll do 120. The needle on the front says it's at the maximum of safe voltage for a household, 120. Turn it off. Well, it turns. It just sounds horrible. I don't know if you can hear it. Yeah, that sounds bad. That sounds real bad. I'm going to grab an amp meter and I'm going to clamp the wire. I want to see how many amps this is pulling. Because she's not working right. She's, of course, the ohms are too high. But I think we just need to get a new motor for this thing. So I'll be right back. I'm going to go grab another meter that I don't have in the house. And I'm going to do a clamp around the wire and see what power she is drawing. Because I believe I'm just going to have to order a motor for this thing. Now, if you have a power strip with the on-off switch that says reset, you can do the same thing. You put one wire on the thin sides and one on the other one. If it's polarized, one will be taller than the other, and then turn it on. Just be careful. There's another problem with this. This is not a grounded motor, which means if for some reason there's a short in this casing and you touch it, it's gonna hurt. So this machine, if it's shorted, it's supposed to pop the fuse that's right here. I don't think it's shorted. You can test it by going from the ground on the plug as an example to the casing. Of course, we all know the ground is the middle or third pin, the big fat guy. So I'll do that just to make sure. We'll test it one more time. I'm getting 18 volt bleed through. And that's what I'm talking about. These are not grounded. So that's why I wasn't touching it when I had it turned on the first time. 18 volts you may not feel. May not feel. So the windings are dying and they're sending power into the casing. But let me grab an amp clamp so we can show you how those work. If you've never seen one, it tells me how many amps this is drawing through this machine. This machine can go to 20 amps before it pops the fuse, and 2,000 surge amps, which means when I turn something on, if it surges, it won't pop the fuse. So that's good. But it comes with about a dozen fuses, and you can buy them at the hardware store. I'll be back in just a moment. All right, so this is an amp clamp. Clamp a wire and it tells you the amperage. This is, I use it in my daily life, this style meter. This is the one I keep at the house though for when I work on cars. What I like about this one is it does AC and DC amperage. A lot of them don't, they only do AC amperage. So how this works is you set it to amps. And I'm going to unplug my leads just so they don't get caught in anything. And then you stick one wire through. Hopefully you can see the screen. Yeah, light really doesn't help. I'm adjusting the setting to see how many amps it's pulling. And it's actually not pulling a lot of power. 0.1 amps. So that's about 1/8 of an amp, and it's fluctuating because the motor's dying. So totally fine. These motors are not high amp draw motors. I wanted to make sure that it's not over amping, meaning that it's shorting out internally to the point where it's going to burn or catch fire. Still going to replace the motor, so I need to order a motor. So we're going to pause here, and probably in a week, whenever the motor shows up, we'll continue. We'll pop the new motor in, and then I will we'll test it again, and we'll put it back inside. And when I was moving everything around, those 3 wires are supposed to be connected to each other, and it makes the skeleton eyes light up and that door here light up, and they work fine. So when I pull this back out to reassemble it, you'll see there's a piece of heat shrink on there because I just twisted them together, soldered them after I test them with the meter just to make sure. But after looking at the circuit board, there was the only way those wires would be. So if they're the negatives. It's a negative wire, so there's no power going to it. The resistors are on the other end of the loop. So those are fixed, that and that. So, all right, well, return to this once I get the part. But if you fix these yourselves, I don't recommend buying one of these unless you have to. These are very expensive units. The cheapest I've seen them for the smaller versions, about 80 bucks. This one's like 2 and change. So if you have a use for it, fine. It's called a Variac. It goes from 0 to 130 volts, and that's what it puts out for power. My input power isn't that high, but it will put out that high of power. So they're kind of neat. But they can be very dangerous because you are working with high-powered AC. So if you're only working occasionally with AC, it's not worth it. I do a lot of these houses that are AC. Department 56 and Mr. Christmas are really good at running AC, which is crazy, but they do. But So if you want a Variac, I'll link one in the description below. But this way you can see it's back on AC. Turn it back on, 120. 144 volts, because it's going past the 130 right here. It says 130 is the max, but as you can tell, it goes way higher. My wall socket only puts out about 118 to 119 consistently. So I'm going to drop it back down to the 120 area. There we go. I was going to take out this analog screen and put in a digital screen to give me more accurate readings, because my needle at 119 is pointing at, the needles right here is pointing at about 109. So this wheel is off. That's why I always plug in an auxiliary meter. That's why I bought the one with 2 plugs on the front versus a single plug, is because electronics always have a percentage of failure, and I wanted to make sure that I could do it. So here's the front of it. As you can see, it's very heavy. But input 110 volt. And there's your max amperage, voltage amperage. And you can see it's just a sweep screen that goes from 0 to about 100. And then from 100 to about 115 is green. And then anything above that is red. They do make a digital screen that fits in here. I don't feel like opening this and replacing it. And the one that comes with the digital screen only comes with 1 plug, which annoys me. So, this is a Variac. You might have seen it in other videos if you've seen it, but there's a better view of what they look like on the front. You can go on Amazon, eBay. They are heavy. You can hear the thud, just me setting it down. And it's a specialty tool that you may never need if you fix your own. But if you want one, just to tool around with, careful, they are dangerous. If they short out, they can make the casing live. Again, dangerous. It does have a fuse, which you saw when I tipped it up, but we just don't want anybody to get hurt. It's a hobby, not a job. You may not need stuff like this. So anyhow, I'm going to order a motor. So I got to get on the internet right now and try and find this guy. If you need to look it up or you have one yourself, the part number or the motor is an AM06. Also, you can use this number, the E181521. I'm going to look up the AM06 first. And it's an precise motor. So, Chinese, just like normal. But anyhow, till the next segment, whenever it comes in, we'll get this thing fixed up and back to its owner. Hopefully before Halloween, since today is October 1st. And if I can get this thing fixed, maybe they'll have it by next week so they can display it before Halloween comes and goes. So, be back in just a moment for you and about a week for me. Alright, it has been a little over a week and I got the replacement motor. Now, the new motor, which is right there, has a short shaft. You can see how short that is. The original motor has a long shaft. You can see the difference. So I had to take the two apart and I swapped out the last gear that drives the shaft. The rest of the gears all have the same teeth, so I could have the long shaft. So you can see it's rotating. Put that back on so that way you can see it turn. Let's turn this off for a second. And for this, the screw is behind this guy. You can see it right in there. I used this tool. You can see the bend. And I'll have this kit link below. And I slowly pried around his feet in his one hand. His hand doesn't want to break free, and I'm not going to break it. But you can see there's little divots in the plastic where the hands and feet go. And on the bottom, there are little pins that for the hands and feet. So whatever glue they used on his one hand is really good. So I don't want to break it or break any of it. So by taking the three out, I was able to flex this enough to where I can put a screwdriver in there and unscrew and screw it back together. So now in my synchronous motor video, I show how to pull these fingers and pop this cap off, this cover. You got to be careful so you don't stab yourself with a screwdriver. But this one's got 4 fingers. This one had 4 as well. And this one had a tall bushing. This one has a short bushing. That's not going to make too much of a difference. The diameters are the same, so we're good. But what I did was, as you can see on this one, like I just said, as I just took the top off and removed, this is how the gears go. So you get an idea what I did. So those are the 3 original gears right there, the ones that are on the pins. This gear I had to swap because the teeth are different. It's greasy. These upper little teeth that drive this gear on this these teeth are the same, but these teeth are smaller. So I couldn't use the original gear. So if I were to put this motor together, which it won't quite go together because this last shaft is a different size, but it would be, the mesh wouldn't fit, and that was my problem. So I had to swap it out. And this will not reverse because the paw, even though it's a different motor base, the paw still engages the notch, and the paw is on the back of this gear. You can see it right there. This is what stops the motor from turning backwards, so it is constantly a CCW. You can see this had the sticker that said CCW CW, and then somebody marked it off, and it only turns in one direction. I've tried stopping the motor, I've tried turning it off and on, off and on, off and on, see if it'll flip back. It won't. So the paw does do what it's supposed to do and keep the motor spinning in one direction only. So now I'm going to put this back together, put it in this house, and then we'll show you when it's done. Also, you can see this has short black wires. They're about 4 inches, 5 inches, 5 inches. This thing has really long blue wires. Color doesn't matter, but these things are a foot, a little over. So I'll probably have to trim them back. Or you can coil them up inside. I'm going to trim them so they don't ever break free of a glue joint and get stuck in the rotating mechanism. And this was already broke when I got it, so I'll probably end up leaving it because it looks like somebody may have tried to repair it. I can't squeeze it together because there's a glob of glue at the base. The glob of glue could also have been from when they assembled this, because this outer ring is separate from the barrel. This is clear, this is opaque, and when they put this plastic disc in with the spiral, the glue may have gotten inside, because if I could, I would push this back together and then re-glue it. I can't get it to move much. It moves a little, but I can't fill in the gap. So the screw will keep it attached. If you make the screw tight enough, it won't, not overly tight like you're going to break it. It'll keep it rotating, and it didn't have a problem rotating. So I wanted to try and glue that back, but I'm afraid if I squeeze it too much, it's just going to snap this piece off because it's broke here. And there's a hairline fracture right there. So, as long as it spins in this ring and it stays centered and doesn't go all sideways like that, I should be good. I'll test it. I'll let these things run for a while before I put them back in the box and send them back to their owners. So this will run for 10, 15, 20 minutes, and I'll check for any issues. I'll also check for power draw. Because this is a 120 volt house, I don't want it to overdraw power. So I'll check for power draw too. So, because this is a 4 watt, and the original one was also, this is 3.7. So this is going to draw a little bit more power, but not much, 0.3 watts. So anyway, I'll be back in a little bit. Reassembly is just the opposite of what I did take it apart. So first thing I'm going to do is reassemble this, put him back in his place. I'll probably put a dab of hot glue in case it ever has to be removed again. I'm not going to use super glue because it would be a pain to take them back out. Probably end up breaking the little character. And then I'll get the house back in here. I'll put the thing back together, and then we'll see it run. So, and I'll put a link for this motor This is the closest motor I could find to this motor, and it still required modification. And like I said, if you watch my synchronous motor video, you'll see how to pop the tops, and you can swap the pieces over as necessary between them. Just make sure you use the new top on the new motor, because even though they look almost identical, 5 holes plus the big hole, they're actually off by a hair. The angle of these holes to the output is just a hair off. So when I try to put the original one back on, the tabs here do not fit into those 2 notches there. They actually are off by about a 1/16 of an inch, or maybe a 32nd of an inch. And that can cause binding, which will prematurely fail the gears, or you can overheat this motor. So we don't want to do that, because that's how you start fires, because these are not fused. So anyhow, we shall return, and we'll go over the whole thing once it's back together. All right. She is all done. Bottom's glued on. Where this rotates inside of that plastic ring, I sprayed a little DuPont non-stick dry film lubricant. So, just to help lubricate the plastic on plastic. So let's turn off the lights. And you can see that beauty. Look at that. Lights are turning on up here, the eyes right there. And then you have the door for the screen, and then the barrel lights up from the 120 volt light bulb. So it is now complete. It's just this swamps out all the other lights. You can see them a little easier if I cover it. This sign is better illuminated by this moon than what the camera is showing, at least in the viewfinder. But it is. Lights coming back. All back together. Now, the light bulb in here is LED. They changed it to an LED bulb, which is will help with heat and longevity and power consumption. So that's always good. But the eyes are lighting up. Those wires that were broke, so I just soldered them back together and put a piece of heat shrink on them. The motor I had to replace but rebuild, because I don't make the long shaft anymore. It's all a medium or short shaft. It does no good. It won't. The drum will be too far in. You can put your finger between the face of the house and the drum. This drum is almost touching the face of the house. And then instead of taping the bottom on, I actually hot glued it like it's supposed to be. So, and she's relatively quiet. You can still hear the motor. Synchronous motors always making noise. It doesn't matter. If you have this house and your drum quits spinning, I'll link the motor I used. You will have to take it apart and build it. I'll link the synchronous motor video below, I mentioned just a moment ago. If your lights fail, it's probably those thin wires broke, because when you shove the plug for the motor in, it coils up inside and puts pressure on those light wires. It's kind of a stupid design. I know why they do it, but the cord could be slightly shorter. It's like 10 inches that gets coiled up inside. It's just too much. That coil has to go somewhere. It's either going to go to the right and rest on the rotating drum, or it's going to go to the left and push on those thin wires. And I think that's what happened, and that's why these lights down here broke, is the coil of wire leaned and then snapped the solder joints. So, but there's really no way to stop that from happening, unless you want to keep that additional plug hanging out the bottom and maybe just have it sitting over here behind your house, depending on how you set up your display. So, but there you go. That's the Department 56 Haunted Funhouse. How to take it apart, how to modify an existing motor that they still make to fit, and if you lose a light, find the wires, check the voltage. It is a lower voltage. That's that little transformers in the front. And put the wires back together. Be careful. Like I said before, this is a 120 volt house. It will give you a heck of a tingle if you touch it while it's hot. So make sure you turn it off or unplug it. I recommend unplugging it versus turning it off, because you can have bleed through a switch. So, but there you go. Thanks for watching. Till the next one.